Okay, so quartic functions, okay, degree 4. So again, if A is greater than 0, it's positive. If A is less than 0, it's negative, all right? So my basic shape, we've spoken about these power functions, x to the power of 4. It's kind of like a parabola. So it's just up, but it just gets a little bit flat bottomed at the, that's all. So possibly we might say that a parabola is more rounded. That's x squared. X to the 4 is just flatter through here. All right. Obviously a negative quartic graph come up and we get a bit flatter and steeper. All right. So it's a more severe U-looking shape. Turning point is here at the origin. The domain of the graph is R. The range obviously is not. So for a positive quartic, it's going to be 0 to infinity. For a negative, negative infinity to 0. Same thing happens here though. Plus K, everything moves up. Minus H inside, we go to the right. And so there's our, whoops, typo there. So there's our general turning point, becomes HK. So let's have a look at a couple. Between the two. So x minus 1. So if we just do a bit of an axis here, so we know the graph's been to the right, 1, 2 down. So my turning point, that's a bad y-axis, isn't it? Oops. So let's go there. Let's put the y-axis somewhere relevant. So we're 1 across and we're 2 down, so we'll call that our turning point. Let's find our y-intercept. X is equal to 0, so we get y is equal to 0 minus 1 squared minus 2, which is 1 minus 2, which equals negative 1. So we'll call that there negative 1 because that one there is negative 2. And so we're going to obviously have something like that. Find my x-intercepts, put y equal to 0. So I'll get 0 equals x minus 1 to the 4 minus 2, take 2 over. X minus 1 to the 4, we get the 4th root, which is 2 to the power of a quarter. X minus 1, so x is equal to 1, well it's plus or minus 2 to the power of a quarter. Okay, so we can label those points. Similarly, what's that going to do? We're going to go to the left 1 unit, we're going to go up 2 units, so my turning point is there. So no x-intercepts in this instance. Put x equal to 0, y is equal to 1 to the 4 plus 2, which equals 3. So we get the point 0, 3. So we see the graph is going to be. So just for all intents and purposes, it looks very much like a quadratic, and you really can only distinguish if you've got them alongside of each other. All right. Same sorts of thing. There's my standard form. Okay, if I have 4 distinct factors, that means I've got 4 distinct solutions, which means I have got 4 intercepts. So intercepts at positive 1, positive 2, negative 1, negative 2. Get a y-intercept. If I put x equal to 0, I get negative 1 times negative 2 times 1 times 2, which is equal to 4. Up here somewhere. So my positive quartic starts in a positive, become down. Who knows whether it is perfectly symmetrical, but we'll treat it as so. So again, turning points, we're not sure about, okay? So there's the key points there. if we have a repeated factor, that makes them turning points, doesn't it? So if the factor is repeated, that makes that value a turning point at that intercept, or that intercept, yeah. So if I want to solve this equal to 0, y is equal to x squared out the front, I get x squared minus 2. So that's equal to x squared, x minus root 2, x plus root 2. So if I want to sketch that graph, plus or minus root 2 are going to be intercepts, negative root 2, positive root 2, but at x equal to 0, that's a turning point. So it's going to be turning it somehow. It's a positive quartic graph. So we start from up here, we go through, I've got to get back to my 0. It's a turning point at 0. And so we have our graph that looks a bit like that. In this instance, our graph is an even function. So it reflects nicely about the y-axis. All right. If we have two repeated factors, it means they're both touching at that point and they're both turning points. So this one in here, so I have a linear factor, I've got a quadratic factor at x equal to negative 2. So it's a turning point. At x equal to 1, that's a turning point. It's positive, so it's a turning point. It comes up. We can work out our y-intercept. Turning point comes up. Okay, so check the y-intercept. X is equal to 0. We get y equals negative 1 squared times 2 squared, which is equal to 4. Okay, finally, if I've got a cubed factor repeated, it makes it a point of inflection, a bit like our cubic graph. So let's do my axes. So at x equal to 2, it's a point of inflection. Yeah, and at x equal to 1, it's an intercept because it's only linear. So at 1, I've got an intercept, and at x equal to 2, I've got a point of inflection. So we've got a positive. So if I check my y-intercept, is equal to 2 times 0 times 2 cubed times negative 1. So it's 2 times negative 8 times negative 1, which equals 16. So my intercept is up there at 16. I come down through. I've got to come up. It's a point of inflection there. So I treat it like a little bit of a cubic graph. So that section there, I'm coming up, and then I'm doing a bit like my cubic graph coming up. So it's a bit like that. Okay? And we decided that point there was 16. Oh, pretty close. Find the coordinates, crosses the x and y axes, and hence sketch the graph. So I've got to factorise, don't I? So the easiest way for us, x to the 4, x squared plus 1, it's so close to being a quadratic, isn't it? So sometimes what helps us, if we substitute away the x squared term, so if I just do my own little substitution to make it look like a quadratic, so if I just say that a equal to x, that means a squared is equal to, a equal to x squared, then a squared is x to the 4. So I could rewrite this as y equals a squared minus 2a plus 1. So that's clearly a quadratic, isn't it? If I factorise that, I get a minus 1 all squared. So what we're saying is that a minus 1 all squared, so y is equal to that. So a is something I introduced, so y is equal to x squared minus 1 all squared. All right. So it says, where does it cross the x and the y axis? So let's solve this. So my y-intercept, I put x equal to 0, I get y is equal to 1. X-intercept, I put y equal to 0, so I put 0 equals, and let's put it in this factored form, x squared minus 1. So if I take the square root of both sides, that means that x squared minus 1 is equal to 0. Therefore, x equals plus or minus 1. So if I sketch this graph, I'll go up here. I've got a y-intercept at 0, 1, x-intercept at negative 1, positive 1. And we have a positive, given that my factors here are repeated, these are also turning points, aren't they? So my graph comes down at the turning point of negative 1. Look, who knows where the other turning point is? Probably there just from symmetry. And we're going to have that. So negative 1, positive 1, positive 1 there. Okay. Okay, just checking the question. Where does it cross the x-axis, the y-axis, and sketch the graph? So we've done all those things. Find the equation of the cubic that passes through. Cubic or quartic, I'm wondering. Probably cubic. So the general formula for a cubic, y equals ax cubed plus bx squared plus cx plus d. So we've got 4 points, 4 unknowns, we have to substitute them in. So I'll set up the equations and we use our calculator to solve. So negative 10 is equal to a plus b plus c plus d, because I put x equal to 1 up there. If I pick the point negative 1, 2, y is negative 1 equals a times negative 2 cubed plus b times negative 2 squared, c times negative 2 plus d, which leads me to minus 1 is equal to negative 8a plus 4b minus 2c plus d. So there's an equation. Let's rewrite this one. Negative 10 equals a plus b plus c plus d. Use the third point. 84 is equal to a times 3 cubed, b times 3 squared, c times 3 plus d. So that gives me 84 is equal to 3 cubed 27a plus 9b plus 3c plus d. Final equation, 426 is equal to a times 5 cubed plus b times 5 squared plus c times 5 plus d. Leaves me with 426 equals 125a 25b plus 5c plus d. I have got 4 equations, 4 unknowns. Use solve. Linear equations on CAS, and not sure what the answer should be, but I'm sure you can work it out.